Hello everyone and welcome to this video. We're going to talk about simultaneity in space-time diagrams. Now, I have also recorded another video where we talk about just the construction of space-time diagrams. If you do not know what I mean by that, you might want to check that video out before you watch this one. I'm going to assume that we have the basic ideas of space-time diagrams down before we go and talk about whether events are simultaneous or not. Okay, so let's go for it. We've got our CT and X axis here. And you'll notice we're only going to consider one frame of reference initially. So this is going to be the stationary frame of reference. We've got two axes there which are at right angles, and I've got my world line for light, which is at a 45 degrees angle, just for sort of reference purposes as well. Okay, so how do we use a space-time diagram to sort of give us some information? Well, one thing we can do is determine whether two events are simultaneous from a particular reference frame or not. So to do this, we simply use the diagram. Okay, now I'm going to add some lines here. You can see I've added some lines, those red dashed lines, to my diagram here. I've tried to make them as evenly spaced as possible, and you'll notice that those are all parallel to the x-axis. Now, why have I done them? If we have some events, okay, so points, and we're going to see what that means in a second. Any two events which lie on a line parallel to our x-axis will be measured as occurring at the same time by an observer in reference frame S. And basically what this means is they have the same time or temporal coordinate, CT. So any two events which appear along one of those dashed red lines is going to be considered simultaneous as measured by S. Similarly, we can draw lines which are perpendicular, in this case, to those dashed lines, and these are vertical lines, and it kind of follows that any two events on a line parallel to our CT axis are going to occur at the same position. In other words, they have the same x coordinates. So when we're drawing these lines, really what we're doing is we're marking all the positions in the space-time reference frame of S which have either the same time, that would be the horizontal lines, or the same position, and that would be our vertical lines. So let's now imagine some different events. We're going to have four events, A, B, C, and D. And what I've said here, they're just random points in space-time. They have a space-time coordinate, they have a temporal coordinate, and they have a spatial coordinate. Okay, now what we could say is, what does observer S see? These four events, what do they mean? Well, this might be a point just sort of to pause and have a think. Which of the events that you can see on the screen, according to observer S, have got the same time coordinate and also which have the same spatial coordinate? So feel free to pause the video at this point. If not, keep watching. Let's think about that first point, whether two events have got the same time coordinate. Well, as we said, they have to be on any of our lines which are parallel to that x-axis. So according to S, as you can see, B and C are going to be considered simultaneous. And what this means is that they occur at the same time. They have the same time point. In other words, they lie on a line which is parallel to the x-axis. Okay, so I could have drawn B and C along anywhere along that nice parallel line, that they're on that fourth horizontal line. Any event along those points would be considered simultaneous. They happen at the same time. However, they happen at different positions. So this could be an example measuring the lengths of two ends of a rod. When we're measuring a length, we measure the end and the beginning at the same time, and they are at different distances. And that could be relevant to our length contraction, which we would see later. Now, we could also look at events A and B here. Events A and B do not occur at the same time. They occur, however, at the same position. They have the same x coordinate. Okay, so I mean, we could talk about C and D, A and D, etc., but really we're just comparing a couple of points here. B and C are simultaneous; they lie on the same point at the same time, and A and B are not simultaneous, but they have the same position. So again, this could be used when we're measuring time dilation, as in two events at the same position, but at different points in time. So far, it's fairly straightforward. When we're talking about the stationary frame, all we do is draw these vertical lines, and don't worry, you don't have to draw them all. We're just putting them in for reference points, and we think about whether they have the same time or the same x coordinate. Now, where it gets a bit trickier, as you've experienced, is when things start moving. So first, what we'll do is we'll add our axes. We're going to take away those dashed lines, and we're going to add some axes here. So we imagine that we are now moving. We're considering another reference frame which moves at a speed v. Now, as you're aware, that what happens then is we add two more axes. That's our ct primed and our x primed axis, and they're tilted at an angle theta. Remember, tan theta equal to v over c. So the faster our speed is, the larger that angle. And we've said that as we approach the speed of light c, we're going to have an angle of 45 degrees, and that's why we put the world line in, really for reference purposes. Now notice I put A, B, C and D still on here. Those are the same positions, same points in space-time. But this time we're going to think, well, what would observer S prime see? Okay. Well, the process is exactly the same. When we're wanting to think about this, we draw lines, or we imagine lines, which are parallel to our x primed axis. And again, any point on a line parallel to the x prime axis is going to occur at the same time as measured by s prime. We do the same for our points of constant position. Okay, therefore we have lines here which are parallel to our ct primed axis, and any point on the line parallel to the ct primed axis is going to occur at the same position as measured by s prime. Key point there being this is measured by different reference frames. And notice really what we've done is we've just kind of squashed the axis there. Everything's been rotated. Notice that these two sets of dashed lines are no longer at right angles to each other, and that's a common misconception at this stage. Now again, we could just ask the same question. What would S prime see? And again, you could take the chance to pause the video at this point to have a little think. What would S prime see? Which two events here are now simultaneous, occurring at the same time as measured by S prime? And similarly, which two events are measured at the same position? I'm going to assume that you've had a chance to think about that. Let's have a think now. If we want to think about from S prime point of view, we're looking at those dashed lines, and we're looking at which events lie on the dashed lines. Now you'll notice there that A and D have the same temporal coordinates. Okay, they lie on positions with the same time, points, with the same time, but different spatial coordinates. Okay, so according to S primed, A and D are simultaneous. Now, they definitely were not simultaneous according to S. So two events which can be simultaneous according to one observer are not necessarily simultaneous according to the moving observer. We could also look at C and D, for example. These guys lie very much on a line of constant position. They have the same position, but they are occurring at different times. So again, where one observer will see things to have the same position, another observer may see them to have different positions. In this case, C and D occur at the same position. However, according to an observer S, they did not occur at the same position. So really, the motion here will cause both our temporal T coordinate and our spatial X coordinate to change, and with the result being that one observer may see something as being simultaneous where the other will not. Now, as I've sort of alluded to, there are a bunch of other things going on here with length contraction and time dilation, etc. But this is just simply how we use our space-time diagrams in order to interpret basic events. We'll look at space-time length contraction and time dilation in a different way in a following video.